So in this lecture, this is a introductory lecture on series. You'll find that series are going to appear in different sections in your physics course itself. Uh, see, with regards to series, I'll only take a sort of brief lecture here. So there are different things. Like for example, you'll find series happening in power series. Okay, so I'll take a few things here itself from power series. A few of the things on basic like it is a basic lecture on series, you can say. Okay, and this is a part of mathematical physics. And again, I would say it is just not the part of mathematical physics, but many of the places you will find the applications of series. For example, you are doing oscillator model. Okay, Einstein's oscillator model in solid physics. So at many places you'll find that we are actually nothing but we are drawing some different conclusions with series. Okay, so this is a brief outlook of what I intend to teach in this particular lecture, and mostly I would concentrate with positive infinite series and also on alternating series as well. Usually, if you are saying exam per se, very less amount of questions are asked, but they're asked. Okay, so I cannot leave this topic as such because that we are beginning again. So I thought let us begin with a few of the initial topics so that initially you just get accustomed to the way I speak and the things I do, and then we'll go for the difficult topics. Okay, so I hope let us start. Infinite series. Okay, so before understanding series, understand that series are related. What we are concerned about is convergence and divergence of these series. We are concerned about convergence and divergence of these series. This is our primary goal. This is our primary goal, that we want to understand that how would your convergence, how would your series converge, and how would your series diverge. And by convergent, I mean, let's say if I'm seeing that, let us say that a series is convergent. So let us say that a series is convergent, then I can assign this particular sum to a unique real value. Okay, if I'm able to assign this to a unique real value, then I would say that my series is converging. And if it is not the case, and if it is like, let's say it is tending towards infinity, the sum is tending towards infinity, then I would say that my series is not converging, right? It is divergent. I hope it is clear. Has anybody got any problem till now? And again, I'm saying this is a most generalized topic. Uh, uh, if you refer to Arfken and Weber, the first topic that they give in mathematics, and they would say that this should be in the mathematical toolbox of every physicist, you can find that this is an infinite series is the first topic in Arfken and Weber itself. So as I promised, one of the lecture will be on mathematical physics, the other lecture would be on quantum mechanics / classical mechanics. Okay, so infinite series. So given a sequence of real numbers, and this is, I think, slightly given a sequence an of real numbers, a formal sum of the form, a formal sum of the form summation an is called an infinite series. Okay, so this is called an infinite series. Okay, always remember that whenever we are going to deal with series, actually we are dealing with series, yes, but we are dealing with sequence of partial sums as well. And what is SOPS? I'm writing it again, sequence of partial sums. Okay, so what do I say? What is a sequence of partial sum? Let us say if I'm writing a series which is summation 1 upon n, I'll write 1 upon k, where k varies from 1 to infinity. This, let's say this is your series. Let us say this is your series. This is conventionally this harmonic series only is there. So let us write it in form of S. Let us say this is your, I'll not even say S. Okay, I'll just say S. Okay, I'll just remark it as S. Okay, let us say this is S. What is the sequence of partial sum to this? I'm just going to write. See, if I'm writing Sn, this would be equivalent to writing k equals to 1 to n, 1 upon k, right? This is infinite till infinite, this is till n. Now you see, if I tell what would be S1, it would be simply 1. What would be S2? It would be 1 plus 1 by 2. What would be S3? It would be 1 plus 1 by 2 plus 1 by 3. What would be S4? It would be 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. All these terms which I'm writing in front of you, these are nothing but these are called as your sequence of partial sums. These are called as sequence of partial sums. And convergence and divergence of this series depends upon sequence of partial sum. If your sequence of partial sum is convergent, then the series is convergent. If the sequence of partial sum is divergent, then the series is divergent. So series behave the same way as the SOPS does. Okay. Is that clear or not clear? So series behaves the same way as SOPS. So convergence and divergence of series depends upon SOPS. So if, let's say, if your SOPS is divergent, then your series would be divergent. If it is divergent, then your if the sequence of partial sum is divergent, then the series would be divergent. If the series is, if this SOPS is convergent, SOPS, mind you, not the general term, convergent, then the series is convergent. So for example, one of the series which actually amuses most of the mathematicians, physicists till now I have seen, whenever I have asked about this series, they would instantly say that this series is convergent, because what they have in their mind, they are thinking about this. Okay, I'm not saying this. I'm saying summation 1 upon n, by which I mean 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Okay, this series is divergent series. I'm going to come over it later on, but just remember, I mean, just keep in mind, I'm not referring to this. I'm not referring to this. The sequence of partial sum to this particular series would be 1, 1 plus 1 by 2, 1 plus 1 by 2 plus 1 by 3, 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, and so on and so forth. Are you getting my point or not getting my point? Obviously, I'm going to come to this point that this is divergent and how it is so, that I'm going to come, but just make yourself convenient with the fact that harmonic series is divergent. I have quite often found people working in physics, especially in relativity, and where all these kind of series you will find in applications, they actually find it very amusing that this particular series does not diverge, because in their head, something like this is going on. Please do remember. Again, in the words of Einstein, the classical physics that we do, or mostly the mathematics right now we are doing, is at times we may be prejudiced. So obviously Einstein had to say about classical physics. He was saying that whatever classical physics you know is nothing but the collective collections of prejudices that you have till the age 18. Okay, and that is what gives a astounding. You can say that is an astounding remark towards the quantum realm, that whatever in quantum mechanics you are going to learn, that is quite counterintuitive. Okay, while whatever you learn in classical physics is nothing but they are the set of prejudices that you have till age 18. So basically what happens is you are quite prejudiced with this particular thing, because you know that this particular function, this particular 1 over n's limit is 0, and by that particular thing you just make an assertion that this is convergent. This is not, this is divergent. I'll explain you, but till now, are things clear? I have discussed only two things. One, what is an infinite series, and how does convergence and divergence of infinite series be understood? So just understand the sequence of partial sum, the structure that is going inside it. Just consider that. If the sequence of partial sum is convergent, then it is fine. Now you will say, how do you say that this particular sequence of partial sum does not converge? On that, I'm going to come a little bit later. But are you getting till now, or is there any doubt, or should I slow down and speak a little bit slow, and then you'll be able to understand? Please let me know. Only 6 participants are there, so I think even if you open up your mic and say things, it won't matter much.
So it's fine, sir.
It's fine. Okay. So always remember the series behaves the same way as the SOPS does. That is the sequence of partial sum. Okay. Now, let us first come to a series that we use quite often, that we use very quite often. Okay, another series, yeah. Okay, another series, you can say that a series, if a series is absolutely convergent, then it is convergent. If the series is absolutely convergent, then the series is convergent. What do I mean by this? I mean by this is, let's say if I'm talking about a series summation UN, and instead of this, I'm saying, okay, just take a modulus of it. And I'm saying that this bigger series, like if there may be positive and negative terms both here. If this is positive, then nothing separates them. So basically, if UN is positive, then taking mod would not make any difference. But if I'm saying, let's say it has some negative terms also. And if I'm saying, okay, I'm not sure about this, but I'm sure about this. I'm sure about this. If I'm sure about this, that modulus, if I take the modulus of each of the terms and I add them up to an infinite, like infinite terms, and if I'm saying that this is convergent, then this is bound to be convergent. Are you getting my point? Let's say one of the series that I'm just giving it to you, summation 1 upon n square. Just remember this is zeta 2. So this is convergent. This you can derive from your Fourier series also. So the value comes around pi square over 6. So I'm just now giving you that 1 upon n square is convergent. Now I'm asking, what do you think about sine n upon n square? Will it be convergent or not? So it is a very difficult thing for you, because you will say, okay, sir, what have you given to us? Sine n would be some way negative also, positive also, because sine n on any day would depend, will be lying between -1 and 1. And we have strictly got no idea as to for what, like how should I think about this series? So I would suggest that don't think about this series, rather think about the modulus of it. If you think the modulus of it, so modulus of it would be less than equal to 1 upon n square. Clearly, sine n ka mod is always less than equal to 1. So if this is convergent, obviously this would be convergent. If the bigger series is convergent, then what about this? And if absolute is convergent, then this is also convergent. So this is a very strong case that if a series is absolutely convergent, then the series is convergent. Always remember this. If a series is absolutely convergent, then this is convergent. What convergence? Series is convergent. What am I saying? Please understand. I'm saying if I'm talking about summation UN, and if I'm not able to assess as to the as to any, I'm not able to put any argument in the favor of convergence or divergence. And if modulus can help me, then that nothing is better than that. Just take a modulus of it and just find whether this modulus UN is convergent or not. If this is convergent, summation modulus UN is convergent, this is convergent for sure. Because on any day, you understand that UN ka mod is always going to be greater than equal to UN. So if the bigger series is convergent, then this is convergent. This is traditionally, I'm going to talk this about this in sense of comparison test also later on. But are you getting my point? These three, you can say Brahma Vakya I've told regarding your series. The first thing is series behaves the same way as the SOPS does. One, if your SOPS is divergent, series is divergent. If SOPS is convergent, the series is convergent. What is SOPS? SOPS is sequence of partial sum. Second number, if a series is absolutely convergent, then series is convergent. There are no second thoughts about it. So if you are not able to assess anything regards series, just take an absolute value of the particular UN term and just try to add them up. If you are able to make an assessment of the absolute value of that UN, and if you can make a series out of it. So if you can make an assertion about summation UN ka mod, then you can say that, okay, summation UN is convergent. So this is another thing that you should remember. Okay, now let us move to one of the series that which we find quite often in physics, that is geometric series. Okay, and we do a lot amount of things out of this. Okay, lot amount of things out of this. For example, again coming back to like, if I remember correctly, the Einstein solid like Einstein oscillator model. Okay, so you are going to find this series quite often in physics. So let us first discuss about this particular series. So this is one of the most important series, and I'm going to write it in the fashion because this is the same series that you're going to get in the complex analysis also. So I'm going to use the right now. So let us focus to. So I'm talking about a series z ki power n, where z belongs to right now. Let us focus to real numbers only. where z belongs to n. Where z belongs to n. Always remember, limit n tends to infinity, a ki power n would be 0 if a lies between 0 and 1, and it would be infinity if a is greater than 1. So if a is greater than 1, then it is going towards infinity, and if a lies between 0 and 1, then this particular limit as n tends to infinity would go towards 0. See why? You can understand. Let's say 1 upon 2. So I'm doing 1 upon 2 raised to power 1. This is 1 upon 2 raised to power 2. This is 1 over 4. Now 1 upon 2 raised to power 3. This is 1 upon 8. The number has increased 50% here. The number has increased to an enormous value. Now you see 1 upon 2 raised to power 10. What it is? 1 upon 1024. So you started with a, sorry. You started with what? You started with 0.5. And after taking power 10, you ended up at 0.001. So how much has your number fallen? So you can say that if I'm going to increase this particular thing, the exponent, it is going towards 0 only. So always remember, limit n tends to infinity, a ki power n is equals to 0 if a lies between 0 and 1, and limit n tends to infinity, a ki power n would be infinite if a is greater than 1. Please keep this in mind. And you know from your standard 11th class, the teacher of higher arithmetic might have taught you that this particular summation happens to be this. If I'm initiating the sum from 0 to, let's say, n, and let's say I'm writing k here. Okay, so if I'm initiating from 0 to n, so how many number of terms are there from 0 to n? From 0 to n, number of terms would be n plus 1. Please keep in mind. Always when you have to calculate the number of terms, please don't make this mistake. If you're subtracting the last term and the first term, add 1 to it. So for example, if I'm saying how many number of terms are from 1 to 100, if you say 100 minus 1, 99, that would be wrong. So you have to add 1 to it. So from 0 to n, how many numbers are there? N plus 1. So I'll write 1 minus z raised to power 1. 1 minus z raised to power n plus 1 divided by 1 minus z. This is the sum. This is the sum that you do. Now, if mod z is greater than 1, clearly this series would be divergent, because for mod z greater than 1, mod z raised to power n plus 1 would go towards infinity. So forget about it. So it is convergent only if mod z is less than 1. Please remember, this is the condition that you should always remember. For a geometric series to be convergent, mod z should be less than 1. Is that clear or not? And if mod z is less than 1, so for example, if mod z is less than 1, then z raised to power n would go towards 0. And this particular sum, that is z ki power k varying from 0 to n, this will turn towards 1 minus 0 upon 1 minus z, to 1 upon 1 minus z. I hope it is clear or not clear. Please let me know. Or am I going too fast for you right now? Okay, good. So now you see, this is geometric series. Now, second series that I'm going to talk about in very brief is called as the telescopic series. The second series in this particular, again, series of lecture is telescopic series. And how do you write a telescopic series? Let's say I'm talking of two terms. Let an and bn be two sequences. Be two sequences such that an is equal to bn plus 1 minus of bn for all n greater than equal to 1. So your an would and now I'm trying to write a series which is of this form. Sn, which is nothing but it is equal to a1 plus a2 plus a3 dash 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 a. So let there be what you can say, let there be two sequences an and bn such that I'm relating an with bn in this fashion. And now I'm saying that Sn is nothing but it is equal to a1 plus a2 dash 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 an. And if I want to write an infinite series out of it, what can you say about this particular series? Will it be convergent or not? So convergence of this particular series depends upon convergence of Bn. Let us now see how. So what would be S1? S1 would be simply B2 minus B1. What would be S2? It would be simply what? It would be simply B3 minus B2, right? Oh, sorry. I should write it in this one. I'll write it here. So Sn is this. So what would be Sn? Sn would be simply A1. Sn would be simply A1. What is A1? A1 would be B2 minus B1. What would be S2? S2 would be simply A1 plus A2. I'm so sorry. A1 plus A2. A1 plus A2 would be what? What is A1? A1 is B2 minus B1. And what is A2? A2 is B3 minus B2. So B2 gets cancelled. This would be B3 minus B2. So your S2 would be B3 minus of where it is going. A1 is B2 minus B1. A2 is B3 minus of B2. Take it. So this is B3 minus B2. Is that clear or not clear? It is B3 minus B1 only, I think. Okay. Is that clear or not? Are you getting my point, or is it not something that you're not understanding?
Yes, sir.
Okay. What would be S3? So S3 would be A1 plus A2 plus A3. So what is A1? A1 is, I think, B2 minus B1. Until now, we have already found that A1 plus A2 is B3 minus B1. So let us not waste our time. So I'll write B3 minus B1. And what would be this A3? This would be B4 minus B3. So always remember the cutting pattern. What is happening? For every bracket, the latter part of bracket is being cut by the former bracket's former part. Are you getting my point? So what will happen if I just write Sn? So if I just go on inductively, I can write Sn would be nothing, but it would be minus Bn minus B. Okay. And if I want to write what would be the series, series is nothing but what it is. If I'm writing this and I'm doing n tends to infinity, if I want to make an infinite series out of it, this would be an infinite series. So basically it is equivalent to writing A1 plus A2 plus A3 plus an, and I want to take a limit n tends to infinity here. Am I making sense or not making sense? Please let me know. See, did you get my point? I mean, I was calculating S1. This was B2 minus B1. I was calculating S2. It was B3 minus B1. I was calculating S3. It was what? It was B4 minus of B1. So similarly, if I go upfront, so what will happen? If I want to calculate what you can say Sn, so what will be left? Sorry, Bn plus 1 will be left. Okay, so what is happening? This is how it is happening. And what is your series? Series is A1 plus A2 plus A3 dash 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 An, and limit n tends to infinity. Or in other words, I can say, what am I doing? I'm summing up all these A1 plus A2 plus A3. ऐसे ही तो हो रहा है. What is happening? So whether I write this or whether I write this, it is one and the same thing. What was Sn? Sn was this, and limit Sn. What is limit Sn? So limit Sn would be this minus B1 plus limit Bn. So only if limit Bn exists, only then you can define a series Sn. Is that clear or not clear? Okay, let us understand it with example. If it is not clear, let us understand it with example. Okay, you'll be able to understand what I'm trying to say. So let us take an example of a telescopic series. Let us take an example of telescopic series, let's say 1 upon n into n plus. You'll instantly understand how to do. See how to go about this particular problem. So what I'll do, and n is varying from 1 to infinity. Okay. So in order to solve this, what I would do, I would make it in a telescopic, I will write it in a telescopic fashion. Let us write some, okay, I hope it is clear. Okay, is that clear? So 1 upon n into n plus 1, I can write 1 upon n minus 1 upon n plus 1. I hope it is clear. See, this is simply partial fractions. You can write this 1 as n plus 1 minus of it. You can write this 1 as n plus 1 minus of it, and then you can do the remaining on your own. Now you just start placing 1. So what would be 1? 1 would be 1 by 1 minus 1 by 2. Put n equals to 2. Put n equals to 3. Put n equals to 4. Put n equals to n at one point. N minus 1. Put n equals to n. So what is happening? For every bracket, the latter part is being cut by the next former part. For every bracket, the latter part is being cut by the former part. So what will happen till this? If I'm just calculating till this, what will happen? For this bracket, this is there. This will be cut by somewhere. So you are getting 1 minus 1 upon n plus. And if I want to take it till infinite terms, so limit n tends to 50. Answer would be what? 1. Is that clear or not clear? Or should I repeat it all over again? Monica, Anshul, Harshit, some other guy has joined. Is that clear or not clear? Okay. Is that good? So now if that is clear, try to solve this series for me. So try to solve this series for n equals to 1 to infinity. I'll solve it for you because we have some lack of time. Okay, so I'll take this mathematical physics section. This is, there are a few questions in TIFR exam that has been asked in a particular series side. So not many questions you can expect in NET exam, but you should remember, you should know all these things. And this is very basic mathematics. Okay. How to go about this series? So what I'll do, if you remember from your childhood, this particular thing, n की power 4 plus n square plus 1 can be factorized in this fashion. This is very easy to identify yourself also, but if you've forgotten, please do remember this. Okay. This is very easy to do. You can do an a square plus, let me do it. So if you do this, this will be n square plus 1 whole square minus n square. This is a square minus b square I've applied. Here you will get n की power 4 plus 2n square plus 1 and then minus n square. This would, you will have only n square here. So in any way, this is quite easy to see that you can factorize it in this terms. And how would you manipulate this n? I would just take a half over outside and I will just do n square plus n plus 1 and then minus of n square minus n plus 1 divided by n की power 4 plus n square plus 1. Is that clear? And what I would do, I would simply write 1 over 2 and summation 1 upon n square minus n plus 1 and minus 1 upon n square plus n plus 1. Is that clear? And n is varying from 1 to, let's say, infinite, but I'll just write n here. If you are getting confused, you can use indexes, different indexes also here. And if you want to find the infinite series, this is how it is. Is that clear? So I have changed the indexes n to k and I have varied k equals to 1 to n and limit n tends to 50 so you don't get confused. I hope it is clear to everyone who is there right now. Okay, so good. What I'll do, I'll write limit n tends to infinity here and I'll take it half outside and see, I'll put 1 here first. So if I put 1 here, I'll get 1. If I put 1 here, I'll get 1 upon 3. Then if I put 2, this is 4, 4 minus 2 is 2 plus 1, 1 upon 3. And if I put 2 here, this is 4 plus 2, I think 7. If I put 3 here, 9 minus 3 is 6, 6 plus 1, 7. And if I place 3 here, 9 plus 3 is, I think, 12, 12 and 13. Okay, so I'll get 1 upon 13 minus, let us do also. 4 square is 16. Just give me a minute. So if I place 4 square, 16, 16 minus 4 is 12, 12 plus 1 is 13, right? And then if I place 4, 4 square is 4, 16, 16 plus 4 is 21. I think 21 I should get. I hope all these things you're getting. And I'm writing. If you, whenever you are doing series, always remember, if you are going to the penultimate term, before writing that penultimate term, always write, before writing that ultimate term, write a penultimate term also. Instead of just writing the last term, also write a one preceding it and one succeeding it. Okay, so that is a good strategy that you can follow. So if I'm writing n minus 1, n minus 1 square minus n minus 1 plus 1 minus 1 upon n minus 1 ka whole square plus n minus 1 plus 1. Forgive me for my clumsiness, but I cannot help it. So, okay, so this is 1, and then you have another term that is 1 upon . Okay, so okay, so now you see, if I just always remember, it is not always good to cut everything. So what I do, even if in mathematics also I teach this, that just don't be in hurry to cut everything at any point of time. Just take a pause, breath, and only then cut. Had you cut all these things and if you would have muddled all these together, then you would have never got anything. If you would have subtracted all these things, 1 upon 3 minus 1 upon 7, then the structure would get lost. So just don't do that. Now you see, in any bracket, the latter part is being cut by the next bracket's former part. In any bracket, the latter part is being cut by the next bracket's former part. In any, and this is like a mantra that you can keep on chanting so that you keep your understanding very still. For any bracket, the latter part is being cut by the next bracket's former part. For any bracket, so okay. So for any bracket, the latter part is being cut by the next bracket's former part. Now this is latter. It does not find a former here, right now till n if I'm writing. So eventually, what am I left with? I would be left with 1 upon 2, 1 minus 1 upon n square plus n plus 1, and limit n tends to infinity. And this would give me what? This would give me an answer as 1. So the series that was looking very horrific to you, how to solve this particular series, this you are getting answer as 1 over. So I hope you've got this particular thing. This is called as telescopic series. This is called as your telescopic series. I hope it is clear. So there is a very rigorous argument for harmonic series, but I'll use a little less rigorous argument for harmonic series. What do you think your harmonic series would behave? How would that behave? So this is your third series in this particular lecture, that is harmonic series. So what is harmonic series? Harmonic series is summation 1 upon n. N equals to 1 till infinity. So usually I use a subsequence kind of stuff when I teach mathematics, but okay, I'm not going to use that. I'm going to use a little easier way of doing it. See, quite often, again, I'm saying I've seen people getting confused by this and this. Please do remember, both of them are two different entities. This is something that you are doing for the general term. You're saying the general term 1 upon n goes to 0 as n tends to infinity. Indeed, yes. But if you're going to construct the sequence of partial sum would be 1 plus 1 by 2, plus 1 plus 1 by 2 plus 1 by 3, comma 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. This is the sequence of partial sum. So don't think that this is your 1 upon n is your sequence of partial sum. No, 1 upon n is not the sequence of partial sum. Sequence of partial sum is this. Always remember, let's say this is your series. So Sn, what is Sn? Sn is 1 plus 1 by 2 dash 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 1 upon n. This is Sn. And if I take the limiting value n tends to infinity, this would be your infinite series. Just see. This particular structure is called as a sequence of partial sum. So S1 would be 1, S2 would be 1 plus 1 by 2, S3 would be 1 plus 1 by 2 plus 1 by 3. So remember, this and this are not same. Okay, just don't get confused by this. So clearly you see that what is S1? So clearly you see that your S1 is 1. What do you think your S2 is? S2 you can see clearly it is 3 by 2. If you think that 1 plus 1 by 2. What would be your S3? S3 is what? S3 is 1 plus 1 by 2 plus 1 by 3. Right? And if you write it in this fashion, instead of writing this, I'll write 1 plus 1 by 2 And instead of this, what should I write? How to get about it? So I'll write it this fashion. So 1.2 is there, 1.2 is there, 1.3 is 0.33, 1.3. Okay, so instead I should write, okay, even if that's not the case. Now, just give me a minute. Okay, so this is how it is. 1 plus 1 by 2 plus 1 by 3. Okay, and what do you think about what do you think about what do you think about S4? Your S4 would be 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, right? Okay, so instead of this, I should make a different sort of strategy. Then things would work. Okay, so I should make a different strategy, and that I'm going to display. So, for example, 1 plus 1 by 2, this I'm going to keep one bracket. 1 by 3 plus 1 by 4, this I'm going to keep one bracket. 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8, another bracket. And this is how I'm going to write things. 1 by 9 dash 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 1 by 16, this another bracket, and so on and so forth. So I think that would be a better thing to do. Okay, that would be better thing to do. Is that clear? So what is happening? Say, leave these two. Just think about this. What do you think 1 plus 3, 1 by 4? Can I write that 1 plus 3 plus 1 by 4 would be greater than 1 by 4 plus 1 by 4? Is that clear? See, if I compare 1 by 3 and 1 by 4, 1 by 3 would be greater than 1 by 4. So this would be greater than 1 by 3 plus 1 by 4 plus 1 by 4, which is 1 by 2. What do you think about 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8? So it would be greater than 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8. Is that clear? 1 by 5 would be greater than 1 by 8. 1 by 6 would be greater than 1 by 8. 1 by 7 would be greater than 1 by 8. 1 by 8, however, would be equal to 1 by 8, but already this side has become greater than this side. So again, this would be greater than 1 by 8. Is that clear? So if I'm talking till S8, so S8, or what should I say? I should say this as S1. What would be S2? S2 would be equivalent to writing S1 is equal to 1. S2 is simply 1 plus 1 by 2, which is 3 by 2. S3 would be 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, which will be greater than 1 plus 1 by 2 remains there. And this is greater than what? It is again greater than 1 by 2. So it is 1 plus 1 by 2 plus 1 by 2, which is greater than 4 by 2. Is that making sense or not making sense? What can you say about S4? S4 is 1 plus 1 by 2 plus dash 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 till 1 by 8. So this will be 1 plus 1 by 2 remains there. Instead, I'm writing this and this. So it will be greater than 5 by 2. So if I want to make sense of Sn would be greater than n plus 1 by 2. Now you see, if I take n tends to infinity, this is going towards infinity. So your limiting term n tends to infinity, Sn is going towards infinity. So if the sequence of partial sum is not convergent, is divergent, then the series is divergent. And if the series is divergent, you can clearly see that particular series is your harmonic series. See what I've done? Instead of 1 by 3 plus 1 by 4, I have written 1 by 3 plus 1 by 4 is greater than 1 by 4 plus 1 by 4. So this is greater than 1 by 2. So S1 was 1. S2 will be 1 plus 1 by 2, which will be 3 by 2. S3 would be 1 by 2, 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. So instead of doing this, I have written that this particular quantity is greater than 1 by 2. And if you go with the same argument, you can write that Sn would be greater than n plus 1 by 2. It is going towards infinity. So Sn is going towards infinity. So therefore, harmonic series is divergent. So I hope I'm done with the lecture today and done with the time as well. So tomorrow we shall meet in one continuous meet where we'll have all the lectures. Okay, so tomorrow you don't have to join with 3 other things. I hope you've enjoyed the lecture. I would wait for your feedback on the group and then we shall see how we are going to proceed. Okay.